Let us understand about application of SR latch as switch debouncer. So we have in the previous classes we have understood about SR latch and its uses. Now this SR latch can also be used as switch debouncer circuit. Switch debouncer. The application is as switch debouncer. Let us understand how the SR latch acts as a switch debouncer. With the help of the circuit, let us see what are the possible voltages at Y and X when it is switched. This is at the time t. Now, when you observe, so this is T2, this is T1, this is V at Y and V at X. So let us understand with the help of a switch how exactly a switch operates. Now let us consider this contact as X and this contact as Y. So this X contact is connected, interlinked between, the voltage V is earthed. So generally in mechanical switches, when center contact is moved from X to Y, so you can see here whenever we take a switch like device, mechanical devices, and when it is moved from X to Y, with the help of the waveform, here you can see at the time T1, here at the time T1, the voltage at X gets to 0. Now you can observe the voltage at X will be 0 initially here. Now when it reaches or it touches the Y, so you can see several make and break operations are happening here due to the spinning like nature in the contact. So when you observe here, the spinning like nature of the contact here we have shown with respect to diagram. So similarly, a similar occurrence can be seen at the point X when the center contact is moved from Y to X. Vice versa, we can say whether it is X to Y or Y to X. So when it is moved from Y to X at the time T2, so again switch debounces this, and the overall effect is called as switch debouncing effect. So if we continue with this switch debouncing effect in any circuit, it is not suggestible as the sparks might arise. So hence it's always better to eliminate using this as an SR latch. Now let us take an SR latch to the switch debouncer circuit. S and R are the two inputs, Q and Q bar are the two outputs. Now let us connect the switch X with same what we have considered, this as V plus and minus. This is your swing from X to, this is your X and this is your Y circuit you would have connected to R point, and this is also earthed, right? Now here when we draw the waveforms using the switch debouncer circuit, here you can see here at time T1, then at time T2 with respect to time T. This is also with respect to time T. This is your Q and this is your Q bar. So here the Q bar comes into the picture. So what exactly is happening as per the circuit here is, so let us consider a contact here as per the circuit diagram of the switch initially at the position X. This is the initial position X. Now initially if it S is equal to 1, so R is equal to 0. So what does this S is equal to 1, R is equal to 0? It results in Q is equal to 1 and Q bar being 0 for the time T is less than T. Now at the instant T is equal to T1, switch is moved from the position X towards Y. So now once it moves from the center contact, leaves X and it reaches Y, we can say at that position S is equal to R is equal to 0, and thus your Q always remains at 1 and Q bar remains to be 0 until the center contact touches the Y position. Now what happens as soon as the center contact here, as soon as the center contact touches Y, the inputs to the latch becomes S is equal to 0, R is equal to 1. Now it's changing and the latch again resets to 0 with Q being 0 and Q bar being 1. So when the center contact is temporarily leaves Y due to the contact bounce. So here what happens, the input becomes S is equal to R is equal to 0, thereby Q remains 0 and Q bar is at 1. So this is what about switch Deboncer circuit, SRS switch Deboncer circuit. Thank you.